Hello everybody, my name is Matteo Ressia. I'm a mechanical engineer and I'm going to talk about visual inspection and magnetic rope tests. How can a competent person decide which is the correct assessment method for each defect? The visual inspection can be defined as the first assessment method for a correct wire rope evaluation. The method consists of deeply looking at the rope, searching for mode of deterioration and reporting the results on a document. In all the updated version of the ISO 4309, the visual inspection has always been considered the first or the principal inspection tool, even if in the last release the magnetic rope test has been included. It must not be confused with a simple search for macro defects. It is a very particular operation and it should be performed by a competent person. A good technician must recognize different defect typologies, such as broken wires, corrosion or waviness. This kind of inspection can require hours, depending on the rope and inspection conditions. The standard ISO 4309 states the assessment method for any type of defect can occur on a rope. The Table 1 lists the more common modes of deterioration and whether each can be readily quantified or needs to be subjectively assessed by the competent person. So, how can a competent person find the defects on a rope? Some defects are usually visible and easily detectable. For other, more hidden defects, a magnetic rope test should be necessary. For example, this picture shows a core protrusion. It can be caused by shock loading as well as improper installation. Rotation-resistant wire ropes on hoists must be installed with extra care and proper handling to prevent rope damage during installation. By introducing twist or torque into the rope, core slippage may occur and it might protrude from the rope. This protrusion is an example of macro defect and it is enough to discard the rope. In this other picture, we can see a group of external broken wires. The square ends of the wires suggest they are fatigue breaks. Hoist wire ropes are subject to a lot of repetitive bending over sheaves, which causes the rope to develop cracks in its outer wires. The smaller the sheave is in relationship to the diameter of the wire rope, the higher the bending fatigue. Once broken wires start to appear, they create a domino effect and much more will appear shortly. This kind of defect can be identified through a deep visual analysis, but grease, lack of light and inaccessibility can prevent detection. In these cases, they can be more easily remarked by a magnetic rope test. In fact, although defects can be clearly visible in some situations and almost invisible in others, they still remain. Valley break is a special defect and it is quite difficult to identify, because the break point is usually located in the valley region between the strands. Valley wire breaks typically occur due to inter-strand nicking, derived from the forces between strands while the rope is under bending load, during spooling and when running over sheaves. This phenomenon is usually very dangerous because the presence of valley wire breaks is a strong indication of internal deterioration in a wire rope. Flexing the rope exposes hidden broken wires, and while doing that, you may hear cracking sounds from the inside of the rope. Of course, bending the rope is not always possible. In this case, a magnetic rope test might be very useful to detect them. So, be careful when inspecting a wire rope, as these are probably the hardest type of wire break to spot. In some types of wire ropes, most of the defects are internal. In low rotational ropes, this happens very often, and the standard ISO 4309 as well describes this phenomenon. The picture shows a low rotating wire rope before and after the external layer of strands has been removed. On the left side, the external layer has no defects, whilst on the right side, the internal layer is full of broken wires. In this case, visual inspection is not the correct method to evaluate the rope condition. A magnetic rope test is needed. Internal corrosion is not so easy to find. It can be visually detected when a red powder is coming from the interstrand zones of the rope. Unfortunately, this is not enough to evaluate the rope condition, because rust can also come from other parts of the plant, like sheaves and drums. Watch out! This kind of defect can be critical in real applications. When suspecting internal corrosion, it's better to perform a magnetic rope test. So, when is a magnetic rope test suggested? A magnetic rope test is suggested every time that the visual inspection is not enough to a correct wire rope evaluation. This picture shows a diagram corresponding to a magnetic rope test in a marine environment. The whole rope was covered with lubricant and was very difficult to perform an in-depth visual inspection. The inspector did not find any problem, and the rope has been declared in good condition. But when a magnetic rope test has been performed, it highlighted a different condition. The diagram reveals a very dangerous situation. There are some zones with a high peak concentration, and this means that the rope is deeply corroded. The rope has been immediately removed, and a breaking test has been performed. The result shows that the residual load capacity was less than 1/3 of the nominal one. In this other picture, the magnetic rope test diagram of a crane rope is shown. This plant is working 24/7, and the rope gets damaged very quickly. For this reason, the device is always mounted on it, to ensure a continuous monitoring. In this case, it's easy to find broken wires on the rope surface, but it requires long planned stops. The magnetic rope test is useful to detect every defect on the rope, to monitor the situation and schedule the planned stop and the rope replacement. So, the magnetic rope test is the only method claimed by regulation for a correct evaluation of the internal condition of a rope. And even if it's not mandatory for external defects, it is the only method that can ensure a quick and accurate assessment of the whole rope conditions.